Chapter 3 Study Guide. Number 1. This is a multi-step equation. The first thing you should do is use the distributive property. When you distribute, 3 times 2x is 6x, and 3 times 2 is 6. Then I bring everything else down. The next step is to combine like terms. 2x and 6x are like terms. When I combine them, I get 8x. Then I'll bring everything else down. Now I have a two-step equation, so I need to use inverse operations. Since my variable is here, I'm going to get rid of 6 first. Then I'm left with 8x equals 24. For the final step, I divide both sides by 8 to get x by itself. My final answer is x equals 3. Number 2 is similar to number 1. I'm going to start off the same way using the distributive property. 4 times 2x equals 8x. And 4 times negative 11 is negative 44. Then I bring the remaining terms down. For my next step, I'm going to combine like terms. Negative 2x plus 8x is 6x. Bring everything else down and I'll have a two-step equation. For the next step, I use inverse operations to get x by itself. Since this is minus 44, I add 44 to both sides of the equation. That leaves me with 6x equals 60. For my final step, I divide both sides by 6 to get x by itself. And 60 divided by 6 is 10. So x equals 10 is my answer. For 3 and 4, you are to write each decimal as a fraction in simplest form. One thought is, if this was 0.4 or 4/10 without the repeating symbol, this would be 4 out of 10. Since it's repeating, though, it's 4 out of 9. And you can check that in your calculator by doing 4 divided by 9 to see that it gives you the 4 repeating. That's simplest form. For number 4, again, if I ignore the repeating symbol and just say 12 hundredths, that would be 12 out of 100. Since it's repeating, it's 12 out of 99. Now I do have to put this in simplest form, so I would divide the top and the bottom by 3 to get simplest form. That gives me 4 out of 33. And that is my simplified form. So repeating decimals are out of 9 or 99 depending on place value. For number 5, we tell whether each equation has one solution, no solution, or infinitely many solutions. First, I would want to simplify both sides of the equation. I can see here that I would use the distributive property first. 5x, and then 5 times negative 3 is negative 15. Then I'll bring down the remaining terms. Now I look to see if there's anything else I can simplify. I can say that negative 15 plus 2 would be negative 13 on this side of the equal sign. So I'm going to bring down the remaining terms. Now this is interesting because both sides look very familiar or similar to each other. I want to get my variables together next. So I would cancel out 5x. Whatever I do to one side of the equals sign, I have to do to the other side. So this is interesting because that cancels out as well. I'm left with a true statement. Negative 13 does equal negative 13. That's true. If I get a true statement or twins, I say infinitely many solutions or infinite solutions. Or you can think twinfinite. Same directions for number 6. We're looking to see if it's one solution, no solution, or infinitely many solutions. First, simplify both sides of the equal sign. I can see again, I'm going to use that distributive property on both sides of the equal sign. 3 times 4a is 12a, and 3 times 2 is 6. On the other side, I have 2 times a, which is 2a, and 2 times negative 2, which is negative 4. Now I have variables on both sides of the equation. My next step is to get my variables together. So I'm going to take 2a, cancel it out, and put it over here. Get my variables together. 12a minus 2a is 10a. Bring down the remaining terms. Don't forget that negative right there. Now I have a two-step equation. My next step would be to subtract 6 on both sides. So I get 10a is negative 10. Then my final step is to divide both sides by 10. And negative 10 divided by 10 is negative 1. So I got an answer. I was able to get the variable by itself and solve. This is an example of one solution. Okay, for number 7, same directions, one solution, no solution, or infinite number of solutions. So here I can see there's no distributive property this time, but I do see I can simplify this side of the equation by combining like terms, and x plus 2x is 3x. And now I'll just bring everything else down. Now these look similar, but they're not identical. I'm going to keep going here to see what happens. I have variables on both sides, so I want to get them together. So since I have 3x here, I'm going to subtract 3x. And, oh, that's interesting. Both x's cancel out. Look at what I'm left with. 7 equals negative 7. Would you say true or false to that? That is a false statement. If we get a false statement, then that's an example of no solution.